Hi, my name is Mehmet Snar and I am an MBG student in Bilkent University. Today I am going to do an experiment where I calculate the equivalent resistance of an RC circuit by using the half-life of RC circuits. First, the capacitor was charged by using a 20-volt DC power supply. Later, the first circuit was formed, where the two resistances are in series according to this demo drawing. The half-life of the capacitor was measured by using a voltmeter and a stopwatch. This procedure was repeated 2 times in order to collect more accurate data. The half-life of the capacitor for the first circuit was measured as 124.1 seconds in the first try and as 123.6 in the second try. The procedure was repeated again with a circuit where the two resistances are in parallel. The circuit was formed according to this demo drawing. The procedure was again repeated for 2 times, and the half-life of the capacitor was measured by using a voltmeter and a stopwatch. The half-life of the second circuit was measured as 35.14 seconds in the first try and as 35.8 in the second try. From the measured half-life values, the equivalent resistances were calculated. The average of the two measurements was 1.787 megaohm for the first circuit where the resistances are in series, and it was 0.512 megaohm for the second circuit where the two resistances are in parallel. The results can be seen on the table. The expected values for the equivalent resistances were calculated before the experiment was conducted. For the first circuit, the equivalent resistance was calculated and expected to be 2 megaohms, and it was expected to be 0.5 megaohms for the second circuit. With these values and the calculated values from the experiment, the error rates were calculated. It was calculated as 10.6 for the first circuit and as 2.3 for the second circuit. The results can be seen on the table. The error rate for the second circuit was small and can be ignored due to small measurement or calculation errors. However, the error rate for the first circuit was high and cannot be ignored. The reason why in the first circuit the rates were high could be a reason of the measurement error of the half-life value and calculation errors due to the wrong measurement of the half-life. Another reason why the error rate was high might be because the internal resistance of the wire was not considered while its calculations. One other reason why the rate was high in the first circuit might be because the DC power supply or the voltmeter that was used for measurements were faulty. However, it is not likely for the DC power supply and the voltmeter to be faulty, since they were used for both circuits. If the error rate is due to the faulty equipment used, the error rate in the second circuit would be expected to be high as the first circuit. Thank you for watching my video.